Now let's suppose we have, I will plot this figure again. This is when positive half cycle of this input AC signal reach to this secondary coil. Now I will consider for the case for the next for the first negative half cycle. So here I will plot my structure again, the bridge circuit diagram again. So here we have diode D1 and here we have diode D2. Here we have diode D3 and here we have diode D4. And here we have the load resistance. This is point A, this is point B, this is point C, and this is point D. This is connected to the transformer. So the diodes are connected to the secondary winding of the transformer. Now let's suppose we have, after the positive half cycle, we have the negative half cycle. So let's suppose this negative half cycle reached to this transformer. Now this S1, this is S2, so this S1 now become negative and S2 become positive because we have the polarity changes here. Here the polarity was from positive to negative. When it's inverse, it's the negative half cycle, then the polarity will change. So this will become negative and this will become positive. So S1 is positive and this S1 is connected to the, S1 is negative, so S1 is connected to point A. So this point A is also negative. And similarly this S2 is positive, so this point B is also positive because they are connected. Now if you look at here, point A is connected, is negative, so and it is connected to P side of diode D1 and N side of P side of diode D1 and N side of diode D3. This is P, this is N, this is P and this is N. Now negative terminal is connected to the P side of diode D1, so it is forward bias. No, sorry, reverse bias. And here the P side is connected to, N side is connected to negative terminal. So here this will be forward bias. So this behave like an open circuit and this behave like a short circuit. CKT for circuit. Okay. Now if you look at this point, this S2 is positive, it is connected to B, so the B is also positive, and this positive terminal is connected to P side of diode D4 and it is connected to N side of diode D2. This is P, this is N. So positive is connected to P side of diode D4, so this diode D4 is forward bias. So forward bias is also short circuit, sorry. And reverse bias is open circuit. So this will behave like a short circuit and this will behave like, this is reverse bias because positive terminal is connected to inside, so it behave like an open circuit. Now we will see the direction of flow of current. So for that I will plot my figure again. So here we have diode D1, D2, D3 and this is diode D4. So diode D4 and D3 are short circuit. They are short circuit. And diode D1 and D2 are open circuit, behave like an open circuit. And here we have the transformer. This is positive and this is negative. No, this is S1 and this is S2. This is point A, this is point B, this is point C, and this is point D. Now the current is always moving, always flowing from positive to negative, so the current will flow from S2 towards B. At point B there are two paths for the flow of current, one is BC and the other one is BD, but it will not follow this path because this is open, so the flow of current will be in this way. And here we have the load resistance, RL. Now at point D, once current reaches to point D, then again we have two paths, one is DC and the other one is DA, but this path is forbidden because it's open, so we have this path for the flow of current. And then once it reaches to point C, then it will follow this path because this is short circuit. At point A, it will follow this path, and then again in this way. So this is the path for the flow of current. So path for the flow of current is from S2 to B, and then from B to D, and then from D to C, C to A to S1, and then S1 to S2. This is the flow of path. Now if you look at these two figures, like if positive half cycle reaches to the transformer, then the current and the load resistor will follow the path from D to C. And similarly, if negative half cycle reaches to the transformer, then the current will follow the path from D to C. So the direction of current is same. So it's a unidirectional current now. And also both positive and negative half cycle will pass through this circuit. So if I plot my, let's suppose this is the input AC signal, this is V input, this is Vn, the maximum value or peak value of voltage, and this is omega t. Then the output after bridge wave rectifier will always be like this. It's unidirectional. Current will flow from D to C, and both positive and negative half cycle passes through this bridge rectifier. So this is the V output, and here we have the omega t. This is 0, pi, 2 pi, 3 pi, 4 pi. So we have 0, pi, 2 pi, 3 pi, and 4 pi. So this is the operational principle of this bridge wave rectifier. Now we will calculate what we call it the peak inverse voltage, PIV. Peak inverse voltage. What is peak inverse voltage? We already define it. The maximum voltage that a diode can withstand in reverse bias is called peak inverse voltage, and it is always represented by PIV. Now I will consider this simplest case. So here, if I look at this figure, I will plot it again, sorry, it's okay. So if we look at here, we have, this is short circuit, so here we have the open circuit, and again here we have the open circuit, and here this is short, and here this is the load resistance, and this is connected to the transformer. Now this is negative, this is positive, and here in between we have the voltage, which is Vm, the maximum voltage, AC voltage. Its magnitude is Vm. Now this is negative, this is positive, So this end will become positive and this end will become negative. And the direction of current will be this one. Current will flow from here to there, and then from here to this way, and then from there to this way, and then from there to this way. This is S1, this is S2, this is point A, this is point B, this is point C, this is point D. Now apply Kirchhoff law. Kirchhoff's voltage law to the path indicated by this arrow, and the path is from here, this one. Here we have, let's look like this. Here look like this, to the path given in this arrow, and then again downward to this one. So I started from this point S1. So I am moving from negative to positive. So the voltage here will be plus VA. If we move from negative to positive, the voltage will be considered to be positive. Then here there is no voltage drop. Here there is nothing else. It's just a flow current for the path for the flow of current. So here we have the output voltage dropped here, which is, I call it V0. So at this V0 is from, we are moving from positive to negative, so its value is taken to be negative V0. And then again we reach to this point, which is equal to 0. From this we get V0 is equal to Vn. So the voltage drop appeared here is equal to the maximum value or the peak value of the voltage of the input output source. Now we will consider, I will draw this figure again. Okay, I will plot this figure again, the same figure. Okay, this is open, this is closed. So this is short circuit path, this is open, and this is again short, and here we have the load resistance RL, along which we have the voltage drop, output voltage drop, which is equal to Vm from this relation. So this is point A, this is point B, sorry, this is point B, this is point C, this is point D. So here the peak inverse voltage PIV appear here. So I will, this is negative, and this is positive. This is positive. Now current flowing from B to D, D to A. So I will apply the Kirchhoff law to this path, because the path of the current is this one. Now apply Kirchhoff law. Law of voltage to the path A, B, C, A, B, C, A. I started from point A. Now this is positive, this is negative. If this is negative, then this is negative, this will be positive. So I started from point A. If I go to point B, D, then we have the peak inverse voltage, which is from minus positive to plus, so its value is positive, PIV. Then I reach to D, and then from D to, if I move from D to C, I'm moving from positive to negative. So here this V0 will be negative, which is equal to 0, or PIV is equal to minus V0 plus V0. And we know that PIV is equal to V0 value is Vm here. So that this is the peak inverse voltage for the bridge rectifier. Now here we will discuss, I will discuss this in the next video, like the advantages of bridge type rectifier.